Hey, good afternoon, everyone. I want to welcome you to another Calculus 2 class. Of course, my recording for yesterday, I published that on the announcement section in case you want to watch the recording. Yesterday, we started different ways of investigating the convergence or divergence of a sequence. I remember I walk you through different methods of doing that. Number one, I walk you through integral test approach. And of course, I remember I also walk you through P series and so on like that. But today, as I promised, I'm going to look into another two tests, two ways of investigating convergence. I'm going to walk us through comparison tests of material, the material already on canvas. I'm going to walk you through comparison tests. I'm also going to walk you through uh, the limit comparison test. Okay, we have two of that, the comparison test and the limit comparison test. Okay, I'm actually going to walk you through that today. But let me go to a comparison test so that you're going to see what I'm talking about. Now, if you want to see what I'm talking about, for us to be able to use a comparison test, if you are given AN, let's say you're given a sequence AN, okay, just like the one you're seeing here, they give you AN or they give you AK to be sequence. You need to be able to get a comparison sequence. So that very comparison sequence will be bigger than the AN, as you can see here. Okay, the AK is less or equal to BK. For us to be able to use a comparison test, we actually need to identify, you know, alternative test sequence similar to the one we're considering. Now, this is the condition. If summation BK converges, the BK is the alternative one that you created. If it converges, then the summation AK converges. That's why comparison test. And of course, if the original one is the AK, the sequence AK, that's the original one. If that diverges, of course, the one you create also going to diverge as well. So that's what we call comparison test. But let me tell you this. In comparison test, we normally use you know a different kind of test, even within the comparison test, like P-series and geometrical test. So I'm gonna walk us through an example. Please pay attention. Okay, in this material, I have an example that I actually are gonna walk us through. Okay, now I'm actually going to go into the example, okay, for if you take a look at what I have, I actually want to use a comparison test. This is a given. Please pay attention. Okay, this guy here, this guy here is the given sequence. It's actually the AK. Okay, it's actually the AK. Okay, I'm calling this guy A source is K. That is a sequence given. But you are going to be the one that will look for a similar one that we call BK, which is actually going to be bigger than that. Okay. Now, for me to see the one to choose, what I'm going to choose is going to be part of the bigger one. I mean, that of the part of the original one. Okay. And this is what I'm going to do. If I actually use, if I try 1 over 2 raised to power k, this is part of this, okay? I want to compare with the whole thing, but there's something I need you to see. Please pay attention. There's something I need you to see, okay? This guy, okay? Compared to 1 over 2 raised to power k, okay? Don't forget, k is positive, right? This guy here is actually going to be a fraction, right? K over k plus 1. The denominator is always going to be greater than numerator, right? In that regard, it's like I'm using fraction to multiply this. When you use a fraction to multiply a number, what is going to happen? The number is going to go down. It's going to decrease. And that was how I know that this is going to happen. That was how I know 1 over 2 raised to power k would be greater than this guy. And how do I know? Because k over k plus 1 is a fraction. It's not, it's not going to be up to 1. In fact, it's not going to be, it's not, let me see. The only condition that which is going to be 1 is, if I say it's not going to be 1, because if you take a look at the k equal to 1, if I put 1, I'm actually going to have 1 over 2. If I put 2, I'm going to have 2 over 3. It's a fraction. When I use a fraction to multiply by that, it's going to be smaller. So that is how I know that this guy here, that's how I know that this guy is actually my AK, okay? The sequence AK, and this guy is a sequence BK, okay? Now, if that is that, before coming to solve the problem, I need to first, figure out what the bigger sequence is going to be. So in number 1 now, the bigger sequence is actually 1 over 2 raised to power k. Now, before I'm going to come to number 2 and number 3, what is in next? After we have found, please pay attention. After we have found that, I'm actually going to show you what is going to be the next. Please pay attention. Now, this is what we're working on, right? And we're able to establish the fact that we're able to establish this fact. You remember from the convergence law or convergence test, 0 less than AK less than BK, right? Which is what we have right now. Now, I'm not going to work with the complicatedest of form of expression. I'm going to work with 1 over 2 raised to power k. So what I'm going to do now, I'm actually going to work with 1 over 2 raised to power k only. I'm going to, working, whatever I get, whatever decision I take with 1 over 2 raised to power k, which is my BK, then I will take decision, about the AK, about the original one. I think I'm going to show you what I'm talking about here. Take a look at that. If I have this, according to comparison test, if I have this relationship, the original AK given and the BK that you form, okay? Now, if your BK converges, if the new one that you formulate converges, automatically your original function converges. Does that make sense? And if the original one diverges, then the new one is going to diverge as well. Okay? That is what now I want us to go to the BK now. We now want to have an analysis on the BK now. Okay? We want to focus on the BK. We want to focus on this guy. Can you see the guy we want to focus on? This guy is the BK that we want to focus on. Okay. Now, if you take a look at what I have here, 1 over 1 over 2 raised to power k. Okay. If I want to rewrite it, I can rewrite that as this. I can rewrite this as this. You're going to ask me how. Now, take a look at this. I can rewrite if I have that. I can write as 1 over 2 all raised to power k. I can write this guy as that guy because 1 raised to power k is 1, then 2 raised to power k. Then when I have 1 over 2 raised to power k, I can write it as this. 1 over 2, then 1 over 2 raised to power k minus 1. Okay? Now, if you take a look at what I have right now, if k start from 1, okay, don't forget from the beginning, k start from 1. This is what I have. Now, if that is what I have, if I want k to start from 0, if I want k to start from 0, automatically, the one that has a power of k minus 1, we have a k. We have a power of k. And with that, I will be able to use a geometric series, a geometric progression. You know, the geometric progression, I'm just having a over 1 minus half. Has anybody heard about sum to infinity in the geometric series? Sum to infinity in geometric is one is I'm actually having a over 1 minus. Now, if you take a look at what I have now, that was how, and that actually give us 1. Okay, the result give us 1. Don't forget, I applying geometrical series. Okay, now since that give us 1, oh, 1 second. Oh, okay, since that give us 1, okay, and by geometric series, when you have a number like that, okay, we actually gonna say it converges, and when that one converges, when AK converges, then I'm actually gonna say this converges. But let me tell you this: if you don't want to waste your time, if you don't want to do all this, if you don't want to, if you don't want to do that, okay, look at what you can do. 1, that is the same thing as 1 over 2 raised to power k. Now, what do we have in the parentheses? 1 over 2 is less than 1. It converges by geometric series when r is less than 1. Okay? If I don't want to go all the way to that, if I don't want to apply that. So this converges. And the moment bk converges, your AK converges. That is the so by geometric series, it converges. In geometric series, when you have when the rate is less than 1, like half, less than 1, half is less than 1. That's a convergence. Exactly what we mean. Okay, so the next we're still under comparison test. Please pay attention. Let's focus on the second one. Now, this is what they gave you. They want you to investigate that using comparison tests. Okay? And how am I going to know? You know, it means your AK is your sequence AK is K over 5K squared minus 4. What do you need right now? You need a BK, right? Now, if you want to get a BK, this is what you're going to do to get a BK. Please pay attention. The BK, the similar sequence that I'm actually going to use in comparison has to come from within. Now, look at what I'm going to do. When K is big, please pay attention. When K is what? When K is big, there's no difference between this and 5K squared. I'm going to say that again. Please pay attention. If you don't understand, ask me a question. Take a look at this. 1 second. Can you see that? Can you see the denominator? When K is large, there's no difference between 5K squared minus 5 minus 4 and 5K squared. There's no difference between this and this. When K is big, because you are subtracting 4 when K is big. Does that make sense? Now, if that is what I have, then I will now consider that K divided by 5K squared. There's a K here, right? K divided by that would be 1 over 5K. Then my BK, and if you investigate out of between this and 1 over 5K, okay? So the 1 over 5K is actually smaller than this guy. How do I know that it's smaller? Okay, if you take a look at, if you compare them, you can try a number, k equal to, for k equal to 1, that would be 1 over 5. Okay, when you plug in k, that would be 1 over 5. If you plug in k, 1 here, 1, and put a k here, I mean, if you put 1 here and put 1 here, I think that would be 1 over, this would be 1. Do you see what I'm saying? If you want to know, and 1 is greater than 1 over 5. This case starts from 1, right? If I want to know which one is actually big, which one is bigger between the two, I can just try 1. When I plug in 1 into the other one, that will be 1 over 5, right? If I plug in 1 here, I think this is going to be 1. And 1 is greater than half. I mean, 1 is greater than 1 over 5. Then that's why we know that that is greater than that. Does that make sense? Now, because if they ask you to use comparison tests and you were not able to figure out the similar sequence to compare with, there's going to be an issue. Okay, now let me now take you to how it's going to be solved. Now, right now, let me tell you this. When we're using approach of a comparison test, we use other tests within comparison tests. Does that make sense? Now, the reason why we call it comparison is, okay, what I'm going to do is, if I'm giving the original sequence, I'm actually going to get a new sequence. And if I analyze a new sequence, when a new sequence converges, then the original sequence converges. How am I going to know if a new sequence converges? And we have to use a approach of convergence that we already learned. Now, like I said, based on what we find out, this is the situation now. Can you see the situation now? 1 over 5k than less than k divided by that. And you remember the way we normally write it? We normally write 0 less or equal to ak less or equal to bk, right? Now you know what your ak is, you know what your bk is. Now you can see what we have right now. Okay, now you know what we want to do. We actually want to investigate this guy. Oh, 1 second. We want to investigate this guy. Because we're only going to choose to investigate the simpler function. Okay, the simpler one. Okay, I can decide to use a different kind, any kind of method that I believe is going to work. But you know what I want to do now? So within a comparison test, I think I told you yesterday, the appropriate test of convergence that you're actually going to use depends on the functional form of the sequence. Now, now I can decide to use an integral test. Okay, I can decide to use an integral test because I have 1 over 5k. I'm actually going to say 1 over 5 SDS 1 to infinity. When I have 1 to infinity, do you remember the way we normally do it under improper integral test? 1 to infinity, I can say 1 to b, where limit b tends to infinity. 1 second. I think I have to switch off this. Thank you. Okay, so now then I'm gonna write a limit. Of course, 1 over 5 SDS is very easy to integrate, which is going to give us ln r, 1 over 5 ln r. Okay, when I plug in infinity, what happened? It diverges. Okay, so you see, according to integral test, okay, when you in integral test, when you are using integral test, when you have an indeterminate value like that, you're actually going to say it diverges. So right now, what we have investigated diverges. Now, do you when this happen, then we're actually going to say that guy, the original function, also going to diverge as well. Does that make sense? Now, what do you think we've done? We've actually used integral tests within integral test within what I'm actually going to call comparison test. I can decide to use any kind of test that I know it befits the structure given. Okay, I can actually do that. Okay, I want to go to the last one. Pay attention. Take a look at this guy. We want to investigate that guy. But you know what? Why do you think we actually want to go for the comparison? We want to go with comparison test. Let me tell you this. The idea behind comparison test is just like the integral test may be very difficult for the complicated structure, and that is why I think comparison test is a way to improve on integral test. Because imagine I was given this particular function, and somebody asked me to use an integral test. This is complicated to do, using integral. But what I can do, I can go by way of comparison test. You know what I'm still going to use integral test, but I'm actually going to identify a very simpler sequence. And situation where the simpler sequence are identified actually converges, then I'm going to say the complicated one converges. Now, please pay attention. If you don't understand, ask me a question. Now, you know what we want to do? We actually want to identify, okay, what we're going to use as, a larger sequence. If I have cos inverse of 1 over k divided by k raised to power 3, okay, divided by 2, obviously, in my new function, I'm going to have that as a denominator. What I have here is what I'm going to have. But I have to look for a numerator where the whole of this is going to be less than that. Okay, I can use a pi. Okay, because this is a trig. Okay, I can use a pi. So pi divided by that is actually going to be, pi over k raised to power 3 over 2 is actually going to be greater than that. And you know what? That is what I'm actually going to work on. Now, I need you to pay attention. I've already identified this guy. Okay, when I identify this guy, what I'm actually going to do, if I want to test that guy for convergence, I'm going to use a P series. Why am I using a P series? Because it is something raised to power something. Look at the denominator, k raised to power 3 over 2. I remember yesterday I walked you through a P series. Does that make sense? In a P series where I have 1 over maybe k raised to power P, when P is greater than 1, then we say it converges. When P is less or equal to 1, it diverges. Now, look at 3 over 2. 3 over 2 is greater than 1. Therefore, it converges. So when this guy converges, then my conclusion is that the complicated sequence converges. Done. Now, what have I done? Within within comparison tests, of course, I've used I can use different kind of tests for convergence depending on the functional form of the sequence. The functional form of the sequence play a very huge role, okay, in the nature of the convergence test that I'm actually going to apply at the end of the day. Is there any question here? Is there any question? Okay, now I think if I were you, why can't you try a lot of questions on a lot of exercise on this. Let me see. Now I just walk you through comparison test. I want to go into another one that we call limit comparison test. Limit comparison test is different from comparison test. At times a test with a comparison test may be inconclusive. Okay, and we may need this limit comparison test. I say yes. Sometimes the expression aka the infinite series is too complicated to compare with the BK of another series. This is another reason to use a limit comparison test. Situation where the AK is actually being complicated to compare. Okay, the one we've been doing using the comparison test, we're able to identify the alternative. We're able to identify the alternative. But let me tell you the way. And because of that, instead of us to use comparison test, we can use a limit comparison test. Now, take a look at what decision is going to be. I need you to pay attention. Please ask me a question if you don't understand. I have a sequence. Go ahead. Okay. You mean to the one we've done before, I've explained? Oh, there. Okay. Yeah, this is also, anyway, yeah, you can write as well. It's also in the lecture notes. I like writing in class. It's sticking to my head when I write in the class. Let me tell you this. Mathematics is like a story. Look at why do I need to go for limit comparison test instead of just comparison test? This is the reason, okay? When your AK, what is AK? The AK is too complex. Your AK is the original sequence given. If it is too complicated, okay, to compare with the new sequence that you formulate, okay, and in that situation you need a test, okay, you need a test. In a comparison test, we did not do limit test. The only thing we did is to apply conventional tests that we have around, like P series, geometric series, integral tests, and so on like that. But this is the condition: your sequence. Please pay attention. Your original sequence have to be positive, have to be greater than zero. The one you created, similar to the original sequence, also has to be positive. Now you know what you need to do. You just need to find the ratio and take the limit. Please pay attention. Okay, pay attention. Take a look at this. I find the ratio of the original sequence given and the one that I actually identify that is similar to the original one given. Then I'm going to find the limit. When I find the limit and the result give a positive finite number. When I say positive finite, it is greater than zero but less than infinity. That's what I mean. Then you know what my conclusion is going to be by limit comparison test. I'm actually going to say, oh my God, this guy and this guy is either both they converge or they diverge. That is going to be the conclusion. Okay. I said it's either the two of them converge or they diverge. Then when I say it's either they converge or diverge, then I will now need to use a further test, maybe different kind of maybe alternative test to now be able to know if one converges, the other converges. If one diverges, the other diverges. But what I can know from the limit comparison test is whether the two sequences converge or they diverge. Like I said, you don't understand? Ask me question. Let's go into an example. Please pay attention. Now, I will be direct in my question. When I'm giving assignment on this, I will be direct. You know what I mean? Look at this question. Use the limit comparison test. I want you to specifically use the limit comparison test to determine whether the following infinite series converge or diverge. Let me walk you through number one. Please pay attention. Take a look at the sequence. Um, Number one, if that is a K, how do we identify the BK? Don't forget, the very first step, okay, is to identify, whether you are doing comparison test or you are doing limit comparison test, you need to identify, a similar sequence, BK. And how am I going to do that? Please, I need you to Pay attention. When k is large, okay, I need you to pay attention. When k is large, 4k squared minus 7 is going to be the same as 4k squared. When k is large, okay. Now, what is the square root of k squared? It's k, right? From there, I can use 1 over k. I can choose 1 over k to compare with. Does that make sense? I can choose one, 1. Like I can just choose 1 over k to compare with. Does that make sense? Now, if I choose 1 over k to compare with, please pay attention. Okay, what am I going to do? I've identified my AK. I have my AK given. I've identified my BK. The BK that we normally want to choose should be a simpler structure. Of course, 1 over k is simpler structure. Now look at what I'm going to do. Please pay attention. Okay, please pay attention. What am I doing here? Limit n tends to infinity. A AK AK divided by BK. Do you see what I'm doing? What is my AK? The original sequence given. What is my BK? The one you create. Do you see how I arrive at that? Okay, do you see why I said that divided by that? Because by limit comparison test, it's going to be the original sequence divided by the sequence, the simpler sequence you formulate from the original sequence. Please pay attention to that. Like I said, if you don't understand, ask me a question. Now, I'm only going to simplify this guy. When I simplify that guy, I'm actually going to have this guy. Okay? When I simplify that guy, I'm going to have that guy. If I have 4k squared minus 7, okay? What I'm actually going to do, okay, if I divide this guy, okay, by k squared, okay, and I divide this guy by k squared, okay? Now, this is what happened. Let me do this so that it doesn't look, this guy is the same thing as k divided by, okay, divided by square root, okay. If I divide that guy by k squared, I'm gonna have 4. Then 7 divided by k squared, and of course, I'm actually going to multiply by k squared. Okay, I'm dividing by k squared. I have to multiply by k squared. Otherwise, I'm actually going to mess up. I'm going to mess that up mathematically. Now, what is the square root of k squared? K. And that k here, we cancel the 1 at the top. Do you see that? When you cancel the 1 at the top, I'm just going to be left with this. I'm going to be left with 1 over square root of 4 minus 7 over k squared. Is there anyone who doesn't understand how I got to 1 over square root of 4 minus 7 over k squared? Is there anyone here? Ask question if you don't understand. Go ahead. Okay, thank you so much. How the k also on top cancel? There's a k square here, right? Do you see this guy? Because when I divide, initially I have 4k, I have 4k squared minus 7. If I divide this by k squared and I divide this by k squared, I have to multiply the whole thing by k squared. Does that make sense? Because if I divide by k squared and I did not multiply by k squared, then I've altered the mathematical setting to be able to tell the world that, okay, they still remain the mathematical, it still remain intact. When I divide by 5, I can multiply by 5, then it will look as if I haven't done anything. Now, the k square there is inside the square root. Don't forget. What is the square root of k square? K. That k will now cancel the 1 at the top. And we're not going to have this. And the moment we have that, set k to infinity. What is 7 over infinity square? 0. I'm going to be left with square root of 4. What is square root of 4? 2. Then I got 1 over 2. When according to the limit, according to the limit comparison test, okay, when the limit of the ratio of an or ak to bk is positive and less than infinity, okay, then You can see that very half now. Then what that mean is that it's either, please pay attention, okay? When that happen, what it means is either they both converges or they both diverges. Please pay attention. Now, but if I want to investigate, so you know what that guy mean? What this guy mean? What this guy mean? It's what that guy mean is that it's either they both diverges or they both converges. Now, okay, you want to ask a question? Okay, go ahead. Uh, okay, okay. Let me clean up. Now you understand it to this junction. You say, how do I get 1/2? Put k to infinity here. This is going to go to 0, right? I'm going to have 1 over square root of 4 minus 0. So what is square root of 4? That would be 2. I get 1 over 2, right? Now when I go 1 over 2, when the limit of the ratio is a positive finite, that is, you have a half is less than infinity. The conclusion here is that it's either both n and bn converges or they diverges. Does that make sense? It's either both converges or they diverges. But how am I going to know whether they converges or not? I will now need to apply convergence test, a different convergence test to be sure. Please pay attention. And how am I going to know the type of convergence test? Please pay attention. Please I know this area is complicated, but if you can just be focused and you ask question when you get stuck, it's gonna be easy. There's a lot of story here. Do you know what I did with the limit comparison test? I got this guy. Whenever the limit comparison test give you a result that is finite and less than infinity, the conclusion is it's either both converges or both diverges. How am I going to know? Because it's either both converges or both diverges. Then what I will now do next is to further investigate. Further investigate the simpler sequence using appropriate convergence test, based on the functional form. What is a simpler sequence? The simpler sequence, please pay attention, is that guy, right? I will now investigate that guy for convergence. And if I'm going to investigate that guy for convergence, you know what is going to happen? That guy is looking like a P series. You understand? Do you remember 1 over k raised to power p? What is p? When I have 1 over k raised to power p, and here is what is p? Can somebody tell me what 1? Thank you so much. And you remember in the P series, when p is less or equal to 1, what happens? Diverges. Okay? Do you not know what I'm going to do? Then I'm going to say both diverges. But by this, the first one I did is going to tell me it's either they both diverges or they both converges. I don't know which one. And for me to know which actually the direction, then what I'm going to do is to look into the simplest sequence and apply an appropriate convergence test. Does that really make sense? So if you want to apply integral test, what are you going to do? That would be integral of 1 over k decay, right? Integral of 1 over k decay. Like I can say integral of 1 over s ds. What is integral of 1 over s? It's natural log of s. Put infinity. That would be natural log of infinity. That diverges. You can decide to go, you can decide to use any other, test that, convergence test that in the literature. Okay. Now, that is that. Let's take a look at this one. Are we ready? You want to take a look at this one? You giving this what you're giving? That is your AK, right? Your AK is this guy. Let me give you the sequence AK. This is the AK. That is your A subscript K. K divided by K raised to the power 4 plus 1. Now, I need you to pay attention. Can you look at the denominator? Do you know what I want to find now? I want to find BK, a similar sequence. And to be able to find BK, please let's investigate. K raised to the power 4 plus 1. When K is big, when K is large, K raised to the power 4 plus 1 will be the same as K raised to the power 4, right? So if it is same as K raised to the power 4, I'm just going to do K raised to K divided by K raised to the power 4. What is that? What is it going to give me? It's going to give me 1 over K raised to the power 3. Therefore, my BK is 1 over K raised to the power 3. Can you see the way I identify my BK right now? Then I'm ready to go by limit comparison test. That's what I'm doing here. The limit comparison test is going to be I'm going to consider taking the limit as, K tends to infinity of AK divided by BK. This is easy, right? Okay. You identify the similar sequence. You see the way I've been doing it, the similar sequence is going to come from the complicated sequence. Do you know why we're running away from this guy? Why can't we confront this initially? Because that is too complicated. We now want to identify a simpler sequence that we can actually work on. Now, so now we're here now. Now we're simplifying. Then, so when you simplify, okay, this is what you're gonna get. Okay, you know what happened here? Please pay attention. There's something I really I wanted to see. Okay, if you take a look at this guy, if I have k divided by k raised to the power 4 plus 1, okay, divided by 1 that, right? If I can write that as k divided by that multiplied by k raised to the power 3 divided by 1. So what is k raised to the power 3 times k? That would be k. That was why I got this. You see that? We do algebra here. That would be k raised to the power 4 divided by k raised to the power 4 plus 1. Now, when we get here now, okay, so pay attention. Okay, now when I go here now, I want to find the limit of that sequence. Of course, use the method of last week. What we did last week, finding the limit of a sequence as k tends to infinity. I will divide everything by k raised to the power 4. Does that make sense? I will divide. So, excuse me. So here, this should be divided by k raised to the power 4. This guy divided by k raised to the power 4. And that guy divided by k raised to the power 4. All of that. Okay? And when I divide by k raised to the power 4, so excuse me, I'm actually going to get this. When I get that, plug in k. Plug in infinity, wherever you see k, what is going to happen? This guy is going to tend to 0, right? Then I'm going to have 1 over 1 plus 0, which is 1. Then when I get 1, what happened? When I get 1, according to the comparison test, when I get 1, 1 is finite and it's less than infinity. Then the conclusion is either AK and BK converges or AK and BK diverges. Then I need a further test. Does that make sense? So whenever you have a value, so it's either it diverges or not. Now, do you now know what am I going to do now? Okay. If I now want to investigate, okay, what is the direction? Because what the limit of the ratio is going to tell me, what the limit of the ratio is going to tell me is either the two sequences converges or they diverge. To know the direction, I will investigate further. What am I going to, can somebody tell me, what am I investigating further? I'm actually going to investigate the simpler structure. 1 over k raised to the power 3. Oh, 1 over k raised to the power 3. I can use P series convergence. And what is P? Here, can somebody tell me what is P? Thank you so much. When P greater than 1, what happened? According to P series converges. And when that guy converges, okay, when that guy converges, you know what I'm going to say? I'm actually going to say the complicated structure converges, done. Then when that converges, I'm going to say that converges, I'm done. I'm done. That's the way to do it. Very cool, right? Okay, so that is the way to do it. Let me do one more example. But before doing one more example, can you ask me a question? I needed to. I think there are some things you need to. What you're going to face here is number one, how do you identify a similar sequence, and after identify a similar sequence, how do you find the limits of the ratio? Okay, how do you find the limit of the ratio? And after that, when you have a result that is less than infinity and it is positive, then you're going to say it's either the two sequences converge or diverge. Then you need a further analysis to be able to figure out the direction. Okay, this is another one. Do you know what I want? I want somebody to explain this to us. The solution is on the board. So can somebody explain that? This is the question. Okay. This is the question. Can somebody explain what happened here? This is the solution. Who is going to volunteer to do that? Don't forget, I wanted to use a limit comparison test. Can somebody try and explain that? So you tell us, okay, what happened here, what happened here, what happened here, what happened here. I've given a sequence and they want me to use a limit comparison test. So what am I going to do? Who's going to help us out? Thank you. Go ahead.
Well, you find a simpler version of that, which is the
I love that statement.
yeah.
You find a simpler version of that. Keep going.
Yeah, you find it's the 1 over k to a half.
Exactly.
And you can do the p-test on that, and it's less than 1, so it diverges. But you have to make sure that the original function is above 0.
Okay. But before you conduct a test on this, okay, I will need to first come here and get something.
Yeah.
Because when I get a number that is positive and it's it's less than infinity, then I first write this. Oh, the two sequences, this sequence and this sequence is either they converge or they diverge. Now, for me now to know the direction, then I will now do what you said. Okay, let me now come to the simpler version of that. And because of the nature of this, 1 over k raised to the power something, that is looking like 1 over something raised to the power p, then I'm going to use a p series. And because p equal to half, right? Now, p equal to half, when half is less than 1. When p less or equal to 1, we talk about diverges. Then we're going to say that guy diverges. And when that guy diverges, then we're going to say, okay, the whole thing diverges. I love this story. It's a very good story. Thank you so much. Let me tell you this. I'm actually going to say this. I remember when I was pushing my child, I have 5 girls. One is going to graduate next year. Has anybody heard about Winona State University? Okay, Winona, you've heard about Winona State. One is going to graduate next year. Oh, go ahead.
But how do you get specifically to one over k half raised to the power?
That's a very good question.
I get the rest, but
Thank you for asking that, because let me tell you this. Moving forward, it depends on your ability to figure out how the simpler version of the AK. Now, I'm going to explain that now. Let me put it. I will explain that now. Now, let me tell you this. The simpler version is going to come from the complicated version. How? Let's take a look at this. You know, This is the complicated, this is the complicated version, right? What I'm going to do, I will look at the denominator first. What is the denominator? K plus 2, right? When K is large, K plus 2 is the same as K. You understand that? Now, I'm not going to write root K divided by K. Now, this is like K raised to power half divided by K. Now, if I have K raised to power half, do you know that here, K raised to power half divided by K itself is K raised to power half times K raised to power half. K itself. Does that make sense? This cancel that. Then what am I having now? I'm having 1 over K raised to power half. So that is how we got 1 over K raised to power half. That's how we get this as a simpler version. So to get the simpler version, it is always, very, very, let me just say essential to look into the complicated structure. In the complicated structure, look at the denominator. Where you are adding a number, subtracting a number, you can nullify that number when K is large. Then you just do algebra. So with the algebra, after you're done with the algebra, then you're going to get a simpler version. Does that make sense now? Did you get the question now? Did you get the answer now? The response now? Yeah, because this is what I have. From from here, I said root K divided by K, right? K plus 2 is the same as K when K is large. Now I want to simplify this. Do you know that this very K is the same thing as root K times root K? You know that? This guy is root K times root K. The root of K here, we cancel 1 here, then I'm going to have 1 over square root of K. Square root of K is the same thing as K raised to power half, mathematically. We do a lot of algebra in math, even in calculus. I normally argue with maybe people doing maths. I normally argue that calculus, 85% of calculus is algebra, if not more than that. We're doing calculus now, but we're doing a lot of algebra. Now is that clear to you now? So which means to be able to arrive with a simpler version, you need algebraic knowledge. You need to do some simplification. But that's going to be super easy. All you just need to do is check the denominator. Because in the denominator, K plus 2 is the same thing as K. It's not far from K when K is large. Then I'm just going to remove that 2. I'm only just going to have a K. Then I'm going to do that divided by that. I will just simplify to get my simpler structure. Okay. Like I said, ask question if you get stuck. Okay. Now, let me see if I have another one. Okay. So, I think, let me say this. What have we done today? I've walked you through two form of a way of investigating convergence today. Number one, comparison test. Number two, limit comparison test. Whether comparison test or limit comparison test, the two of them involve you trying to get a simpler version of the given original sequence. Okay, the two of them involve that. Okay, so and let me also say this. Why do we move from comparison test to limit comparison test is because at times this is what happened. In the comparison test, this is the difference. In the comparison test, what we normally do in the comparison test is to identify a simpler version, and after getting a simpler version, if one converges, we're going to conclude that the other one converges. Okay, but in a situation where the given sequence is highly complicated, where you are not able to compare that with whatever you think about, then what we're going to do is we're going to conduct a limit comparison test. And in the limit comparison test, we're just going to find the ratio. Don't forget, what you're going to put on the top will be the original sequence given. What you're going to put in the bottom will be the simpler version that you actually figure out. When you find the limit of that, okay, when you're finding the limit, don't forget, today we did not use L'Hopital's rule. When you are finding the limit, there's possibility you may resolve into L'Hopital's rule, where when you plug in the infinity, it may be infinity over infinity. You're going to differentiate the top, differentiate the bottom, put the limit again up until you have your result. Now, if you have a positive value, if your result is positive, which means it is less than infinity, then the conclusion is that the two sequences either converge or diverge. But for me now to be able, it means I need a further convergence test to be able to identify the direction. And what do I need to do? I will now go back to analyze the simpler version. Now I will look at the simpler version for me to be able to know the appropriate convergence terms to use on the simpler version. It depends on the functional form. Because I know this guy is 1 over k raised to the power 3. Oh, that's looking like a P series. I can just go by way of P series convergence test. You know what we're going to do tomorrow? We're going to consider ratio tests. Okay, there are other different kind of tests. We're going to talk about ratio tests. We're going to talk about absolute convergence tests. There are different kind of ways of investigating tests of convergence. That's all what I have for you today. Thank you so much. Can you grab that for me? Thank you. Okay, so it's time to turn in. For those of you that have not turned in, aside homework 8, turn them in. Then I'm going to post homework 9 after today. Thank you so much. Thank you. Okay, that's all I got. Always check the announcement section now. I've been posting the videos. Thank you. I've been posting the recording. That's all I got. Make sure you all stay. Thank you. Thank you. Oh yeah, that's okay. It's okay. Thank you. But yeah, thank you.
No, I said,
I didn't see you yesterday. Are you okay?
seeing you miracles.
Oh, you said yesterday when? Oh, yes, it did. I will check to you. At times I check 24 hours. It takes 24 hours for me to. Are you okay now? Make sure you relax, okay? No. At times it happens, you know. Oh. Oh.